Thanks, Josh. Okay. Are we good? Or am I too loud?
Yes.
It's echoing a little bit, I guess. I'm good now? Good? Okay. So, I think we have reached, we are getting close, as Ben mentioned, to the end of this conference. And I want to take you to the home stretch, so as to say. Okay. So with that said, today I want to talk to you about, up until now, we have all had a chance to talk about OVS from a performance point of view. I think we have had excellent presentations about numerous ways to actually improve performance of OVS. And I was just wondering as to how many different efforts are actually going on just to improve performance. Okay. One other thing that I was actually looking at was, okay, how do we make sure that these things actually get deployed? And apart from deploying just on OpenStack and some of those other things, can we do something else? And what I'm going to talk about today is basically about the SDN control plane. One of the other things that has not been talked about much in this conference up until now is, apart from the last talk where I heard a little bit of OpenFlow, this talk is going to exclusively focus on OpenFlow and SDN. Okay, so with that said, Faucet is basically an SDN controller which can help convert your SDN OpenFlow switch, namely an OVS or other kinds of switches like that, into a regular L2, L3 switch, but with SDN functionality. You might say that it is actually done right now and that kind of stuff with OVS a little bit, but there are other things that we can actually do. And I'm also going to talk about more in terms of what other SDN functionality that can be actually done and what does it really mean for network operators and that kind of stuff. The other thing is that it's all written in Python, okay, and it's all Apache 2 license. And we will again talk about why this is actually important from a programming point of view. We are focused on deploying this for enterprise and campus segments. This control plane can actually work for others, whether you want to deploy it for service providers and data centers and that kind of stuff. Yes, it can be, but we are focused mainly on use cases. So we will look at campus and enterprise segments as the main ones. There are a few different personas who are actually involved in deploying this. So that's basically the network operator, you have the security team, you have the operations manager, and the business user, and the application developers. So these are all the different people who actually are going to influence as to whether how the control plane actually works and what does it mean to actually use the network and so on and so forth. And we want to do SDN because unlike a Cisco switch, we can actually do a lot more additional functionality, and which we will also talk about. How do we differentiate? Many times, I think you guys have all played around with a little bit of controllers here and there. The biggest challenge is how do we get this thing up and running? And if you have looked at OpenDaylight or ONOS or all of that stuff, there is actually a significant learning curve, even though you have to deploy VMs and that kind of stuff. You still have to configure it, you have to make it run and that kind of stuff. So with this, what we have looked at is the controller itself can be installed in 30 seconds or less because it's a pip install. Yeah, 30 seconds. Yeah, I will show it to you. Okay, pip install. And then the other thing is that we want to get a network up and running in about 30 minutes. Okay, so that's basically the model on which we started to work on. And the other thing is that many times we have also talked about how do we upgrade a policy or configuration and that kind of stuff on a regular switch, and how do we, when we have to restart a controller, is the switch going to go down? Can I bring down my network? I want to apply a new policy. How can I do all of that stuff? Again, we want to do all of that stuff while the network is running, and that has been built into this controller. Then the network operators don't really understand match action rules. I mean, in this room, I mean, we can all talk, anybody can talk to anybody using match action rules, okay? Everybody understands it. But when you go and talk to the network operators or the security teams, they'll go say, what are you talking about? I have no idea. All that they care about is a configuration file that they can go and say, hey, can I edit this? If I edit this ACL to say mirror everything from port 1 to port 11, that's something that they can actually write. If it says go here, mirror, and then to that corresponding things, and they're happy. And it needs to be a text file, nothing more. Or they need to have a tool that you can actually push. Okay, so those are the only two things that are actually acceptable, and that's something that we also enable. There are other things like how do we network operations are very important for when you have to deploy such a system on the network. How do we get information about what kind of switches we are connected, stats that are associated with it? Do I have to integrate with other kinds of networking pieces of software in order to make all of these things happen? Those are important. That's also taken care of. We have built-in dashboards and everything. Then there are other numerous applications that come in terms of how can we, right now when you plug in your machine to the network, in a legacy network, I should say, basically you have to do all kinds of things in order to make sure that when you unplug that network and somebody tries to use that same IP address for that on that port, he doesn't get access and that kind of stuff. You have to write all kinds of tools and methodologies in order to make all of those things happen. But with an SDN, it's just a it can actually be built into the ecosystem without you having to reconfigure and do all kinds of things. The other thing that we also talk about is a built-in test suite, which we will talk about it in the upcoming slides. So when did this all start? This started about a year and a half ago. The original authors are Chris and Brad, who are in New Zealand. And they developed this. They had around 700 lines of code, and then Josh contributed to it. Josh Bailey from Google, he contributed to it, and he has been working on this ever since. We have had significant updates to that. A year ago is when I started to work on this. We have made the installation extremely simple. Now we have pip installs, we have VMs, we have Docker packages and that kind of stuff, so that we just want to get you up and running in no time. And one of the other things is that from a production point of view, they want things to work, and they want things to work in the way that they are used to, and we have made those things happen. Of course, have been supported by ONF, and this project is also supported by Google with engineering resources and everything. Where are we deployed? Okay, before I go into the details of it, I want to tell you that this is actually real. Okay, and this is not an experiment. This is not proof of concept code or anything like that. This is actually production quality code. All the code is extremely well documented, and we follow all kinds of software methodologies in terms of test suites and everything. And this is actually deployed all around the world, at least in about 11 locations, and in production. Okay, when we talk about deployment, we're not talking about deploying it in my lab, but deploying it for my in trying to run. I deploy it in my own house, okay, and that is how I connect to the internet, okay, and do all the things. So if you don't hear from me, whether my WebEx call fails or so, there is probably a network problem, okay. So it's not me. I'm not sick. I never get sick. Okay. By the way, one other thing that we also did was that, okay, in order to demonstrate that we are actually real, we did two things. We actually deployed this at SDN Hackfest, which we had a few months ago in Bangalore, India, where we had around 100 people and around 150 devices, I think, that got connected into that network. They were all running. They did not know that we were actually running an SDN OpenFlow Wi-Fi for that entire show. They had their phones and their laptops connected, and they were all writing code and that kind of stuff. So we used it, and I will talk more about that. And also at the ONF Member Workday. This is the Open Networking Foundation Member Workday, where they created the OpenFlow standard and everything. So we had it running for a couple of days at the Marriott Hotel down the street here, and for about 220 users, and we had around 8 gigabits of traffic that went around. Nobody realized anything. We had around 7 APs going back and forth, and everything worked fine. So this is real. Okay, we can actually deploy it. And by the way, for all the performance geeks out here, Nobody complained about performance there. I don't know why. Okay, so I think one of the things that I would really like to do is I want you guys to deploy this at the end of the show and really see whether this is this is going to improve the performance of your users in real life. And you can also do your tests. I mean, I'm not saying don't do your tests, but go ahead and deploy this and also try and find out if this actually works in real life. Okay, what do we have in terms of our production? Are you guys able to hear me? Okay, good. In terms of code, we have around 5,200 lines of code at this point in time, and we have another 2,500 lines of test code. It's all written in Python. As I said, we have different varieties of installation. We have over 40 developers who have actually contributed code to this up until now. The contributions have come through various different sources apart from me and somebody else writing code and that kind of stuff, but it's also been through the Hackfest. One of the things that we have is that we have Hackfest where people come and write code to projects defined by us, so they don't come around with ideas, but we actually give them what needs to be written and with specific requirements so that they can actually write that stuff with a goal to upstream it into the main source tree. So that's one of the ways that we have actually gotten a lot of code developed too. Okay, one example being the NoSQL database integration that came into Faucet was actually through one of those Hackfests. Okay, and we have data plane support with not only open source software like OVS and Lagapus, but also through regular production quality hardware such as Allied Telesis, NoviFlow, and many others, HP Aruba, and so on and so forth. And I don't know how many of you guys know, but there is actually vSwitch running on OpenWRT. So you can actually go to Fry's. I think, the latest, somebody did a policy mistake when they were actually trying to say, we want to block some of the Wi-Fi spectrum and that kind of stuff, or we want to lock them in. So now you cannot go back and reflash your ASUS router, which you can buy for $100 with OpenWRT anymore. Okay, so that is not possible, but you can still go ahead and buy an Intel Atom and that kind of stuff and reflash it. But if you have the older versions, if you haven't updated the new piece of software, you can actually reflash it with OpenWRT and enable OVS on it, and you can control it through Faucet. So that's a $100 switch for you. Okay, so I'm now going to talk a little bit about the design philosophy, which is extremely important. I mean, many times we get asked this question, okay, there are a million different controllers out here. I thought this problem was already solved. Why the heck are you guys doing any of these things? Okay, so let's talk about that. Vendor agnostic support. If you have gone and looked at many of the other controllers, the first thing that they do is that, okay, hey, we support all of these switches. We write all of these agents in order to make all of these switches work. But what we are saying is, hey, can you please follow the OpenFlow spec? OpenFlow spec basically says you have to give us access to multiple tables and group table support. Okay, that's all we care about. Give me access to that, and so that we don't have to write any custom drivers. All the switches that I talked about, they provide the same access, and we can actually use them. That means we don't want any custom OFDPA pipelines that are going to be embedded into the hardware. So all the custom, the OFDPA pipeline, we build it in software and then put it onto the switch. And there are advantages to that, which we will talk about. One of the other things that we do is that we also don't, we try to minimize the packetings that come in from the switch to the controller. The only things that we basically look at is when there is a change in the port, that means a new host has come in or a host has gone away and that kind of stuff, in order to do the topology understanding, that is the only time that we get packetings. Most of the other things, if you have written all the code correctly in terms of match action, you should actually send it to a particular port and process it accordingly is our philosophy. Okay. Second thing is that we also try to do a division of labor. That means we have two controllers in a way. Okay, one controller is called Faucet, the other one is called Gauge, okay, which is running in parallel. Faucet is basically trying to maintain all the switch connectivity, trying to set up all the pipelines, and then flow table management and packetins and all the other things, learn about the topology. Similarly, parallelly, we have another one called Gauge, which is basically looking at its only business in town is to look at all the switches that Faucet manages, but in a read-only mode. It basically is reading flow table information and the OF stat information. And it is taking all of that information and storing them either into CouchDB for flow data or on InfluxDB for stat data. So with this, all the applications that are higher up in the food chain, they're basically talking to Gauge. Okay, so we don't have an add or a delete API or anything like that, which I'm going to talk about. But they're basically looking at this database. Now you're programming to CouchDB and you're programming to InfluxDB for all of the information. How nice is it is. We don't have an explicit API because of that. Okay, so now you can use the standard thing. So I can go get a web developer, JavaScript CouchDB developer who can actually do all of these things without even he having to understand what OpenFlow is. And that actually is a powerful statement. Control plane upgrades, we can actually do service faucet restart, those kinds of things, which are very, very important. That means while you are running the network, you can actually do in-place upgrades and without having to bring down the switch or the network. As I said, there is no external APIs, which I talked about. And we follow the Google service reliability engineering kind of a thing, SRE model of push on green. That means you have a test suite. We have a test suite that works with Mininet. You write your application, make sure that it actually works with Mininet. Then with just a configuration file change that, hey, can you please run the same test suite on a piece of hardware, and it will actually run all of that stuff on that hardware, and you're all set to go. Now you can actually deploy it in production with confidence. So that's the other thing. And we have all kinds of SDN configurability kind of a thing in the configuration files itself. So we have the learning mode. You can actually turn on unicast learning, unicast flooding for that matter. Otherwise, you'll be flooding everything in turning on or off. Instead of flooding all the ports with information, you can actually say, hey, send it only here and that kind of stuff. You can actually configure routing algorithms. So we have a fabric, distributed fabric, on which we can actually do all of these things. You can say, hey, I don't like this kind of a routing algorithm, but I want to change something. I want to create my own for various different reasons. You can do that. You can do ACLs. You can do policy-based forwarding, like mirroring example that I was talking about. And the other cool part of it is that we also have something called as a stacking of switches. So what we actually support is a whole bunch of vendor-neutral stacking of switches. That means you can have Allied Telesis, you can have NoviFlow, you can have Corsa, you can have OVS. You can have all of these switches. Let's say that they all have 70 ports each, and you have 10 of them. Do you want to make it look like a 700-port switch? You can do that with just a configuration. Or you can make it into 7 100-port switches. Okay, how nice. And this is actually the power of SDN that we really talked about early on. And this is actually possible. You can actually deploy Faucet today and make these things happen. And this is the kind of pipeline that we are talking about. Today it is in software, and that is what we want to push. Tomorrow we might say, hey, this is, I just created MPLS as one, I added MPLS support into this. I will add one more table support out here, or 2 more, how many ever that I need, and I will push it. This is a software OFDPA pipeline that we will actually push it onto the switches, and it will just work. I think that's another cool part of it. We don't support any vendor-related, vendor-specific pipelines like OFDPA because we can't. There are other things, okay, so in terms of when we looked at it, we also wanted to make sure that the control plane security is enhanced. We have, apart from doing TLS or MACsec security onto the switches, we can actually do deny all and that kind of stuff for all the ports. So you can do all kinds of configuration in order to make sure that your controller and the switch communications are secure, and also you enable all of these functionality. With that, there is also what we do, something called as a expiry time on all the flows. So when you lose connectivity, when the switch loses connectivity to the controller, we can actually, we expire it based on the expire timeout, okay? So the switch keeps running, but if the controller does not come up, it will not learn new hosts, but it will keep working, okay? So those are some of the things that we can actually do. High availability is something that can actually work in this. It's an in-memory controller. It does not rely on any disk. And you can actually have more than one instance of Faucet, and it will automatically work because of the pipeline that is there. So you don't have to do any intra-controller configuration. From a scalability point of view, as I said, we can support any number of ports or switches. There's nothing limiting in terms of making sure that all of those things can actually not happen. By the way, the 24,000 flows, so at the SDN Hackfest in Bangalore, when we actually did this, when the Couch TV guys said, hey, we are ready, and we connected, we said, okay, what's your controller IP? We just programmed the switch to point to that controller, and they got in 24,000 flows. That's how many that they had. So nobody complained, so everything was working fine. One of the other things that we also do is that we support NFV offloads. So DHCP, DNS, NTP, IDS firewalling, 802.1x, all of that stuff can actually be offloaded onto the other services which we don't provide or which we rely on a network, for example. So those kinds of things can be easily addressed. As I was talking about in terms of network operation and analytics, so we have real-time integration with Grafana dashboards because Grafana and InfluxDB work very well. You can actually configure it. You can get all kinds of things. Network operators are very happy with this. This is roughly the picture, an architecture picture that you can look at. As I was talking about, you have the Faucet controller on one side, which is basically doing all that stuff in terms of maintaining switch connectivity. On the other side, you have the gauge, which is trying to manage, look at all the flows, and provide it to higher level applications for other things. This is one example of a deployment. Okay, you can see a picture here. You have a wireless access point. You have switches and that kind of stuff. It can be as simple as this. I mean, you don't have to break the bank in order to deploy this. Okay. And this is yet another example. You can go, all the slides are going to be available. I've made it a little bit more pro so that you can actually go, all these IP addresses and everything, I mean, you can actually make it work just like this. And this is actually how it is being deployed at ONF offices. Our developer profile is just Python. Okay, experienced Python programmer is all that we care about, nothing else. Only one skill set required. That means to say that when you hire 10 developers, you can mix and match, you can let them work on anything that you can actually do. These are some of the references. I have a whole bunch of URLs. There's an excellent article on the ACMQ, which has been made available to general access on the entire Faucet and all the things that I talked about. You should go check it out. It's right here, Faucet deploying SDN. So that's another thing. You have blogs, you have installation guides and everything. Call to action is deploy an SDN-based wireless network. You can get a lot of clients, and you can test your own network. You can get real flows as compared to simulating it from XCS, FireInt, or writing your own custom tools. So that's what I would do. And here is something. This is what Stefan uses. This is a 4-port Zodiac switch. And this is a Raspberry Pi. Faucet runs on this controller, Raspberry Pi. And this is a 4-port switch. And you can actually have application developers actually write to all of these things. So that's the power of it. And this one costs around $75 US, and this one is like $35. So for about $110, you can have a complete OpenFlow switch. And this is OpenFlow running OpenFlow 1.3. So the next event that you want to do, and if you want to run an SDN Wi-Fi, talk to me, please. Okay, and I want you to run your OVS switches with different performance, with optimizations and that kind of stuff, and may the best one win.
Thank you.
Thank you. We have time for one question if it's quick.